Daniel.
Thank you very much, João. So basically, my colleagues have presented you the hardware, the technology behind the Future Cities project. And now I'm talking about applications to the data that is being collected. And how can you look into a moving network? So these images show in Porto downtown, and you can see access point, also called by roadside unit or RSU, which is basically a hotspot connected to the fiber of Porto Digital, which has an interface for long-range communication with vehicles and interfaces for Wi-Fi hotspots as we know it. And we can see buses that have, in addition, they have cellular for backhaul, and they have GPS, which enables us to track them. And these are vehicles talking with access points, as we can see in this video. So basically, we have buses going on Porto City, but not just buses, garbage trucks, and taxis. And they are communicating with these access points, transmitting data, receiving data. So what can we do with this? How can we take advantage of this technology to better understand our city? And here's the city of Porto and neighbor cities. But actually, without censoring, without any kind of technology, we can't have a sharp look at Porto. Porto is just a gray area that we don't know exactly what's happening. And common strategies that were explored previously in other projects are based in placing some fixed stations in the city, but they only give us a very local perception of what's happening in the city. These in the picture actually are the access points that we have installed and the range they can perceive. And what we will see now is how having this technology in the vehicles, having vehicles that are capable to grab information from the city and then transmitting this information to the access points can deliver a low-cost solution that enables us to see what's happening in the city. So we are not actually looking to the present, we are looking to the data that is coming from different sides of the city in a low-cost fashion, in a delay-tolerant network. And we can see that after an hour that we have just seen, most of the city was covered, and we can have a clear picture of the city. So this is the delay-tolerant network and the opportunistic communications that my colleagues have been talking about, and here you can have a more or less understandable picture of what is it. And how can you use this to our advantage? So one of the things that we've done is doing fleet mobility analysis together with the bus company, SCCP. And this is a case study where we have analyzed 1,000 trips of a bus going down Avenida Fernão Magalhães, and we have described the profile of speed along this trace, along this street, to understand where the buses were losing more time. And they were losing time on bus stops, of course, and on crossings. But actually, they were losing more time on red lights than picking up passengers. And this has motivated other lines of research, like synchronization between red lights and buses. But this is the results. In particular, what we can see at blue, all the moving time varies along the day, and we can see a red, how much time do they spend on bus stops and on other stops, crossings, basically, and on green you can see the time they lose on bus stops. But one thing that should really emphasize is that this kind of study is only possible, at least in an economically feasible way, because of the delay tolerant network solution that we use. For precisely quantifying how much time a bus spends in a bus stop, we use delay tolerant networking to deliver second by second GPS data. This is like 13 times more than a typical GPS tracking software solution can give you, because we use delay tolerant networking to avoid expensive cellular data. Other case study that I'd like to share with you, and this is quite near actually, near this site. Here we can see Hospital Santo and basically there was, and there still is a big problem here, where a lot of buses lose a lot of time. There's a bus stop here that make all this traffic, and there are a red light here, which also doesn't help. And the city council, together with the bus company, they decided to open this way to let only to buses. And here, with the data collected by the Future Cities and by Veniam, we can see how the flow changed, the flow of vehicles changed here. And you can see that this area here was pretty much alleviated. Okay, we still have a problem here because of the red light, but there were definitely improvements in moving and creating this bus stop and opening this way to traffic. Okay. Now, passenger mobility analysis is a different topic. We have seen how buses move in the city and how we can analyze how they move. But now I want to talk to you about how can we try to understand how people move using the bus system. And the STCP free Wi-Fi service was already presented here. And people log in and log out. And the idea here is making use of that data to understand how people move in the city. Okay, we're not talking about all the people, but at least people who use smartphones and laptops while they travel in their bus. So what we do is we use the time and location when a passenger signs in the network to have an idea of what's the origin of his travel, of his trip. And when the passenger leaves the bus, it automatically signs out, and we also record that location and the time when that happened. This enables us to have, the good thing here is that passengers don't need to have any software installed. If they have their Wi-Fi on, even if they are not using their smartphone, the smartphone automatically signs in the network, so we can automatically track where do people go to and where do they come from. And this is what happens if we plot the origins and destinations and we just put straight lines connecting them in a map. Okay, we can't take a lot of information from here, so we tried several different strategies. We tried clustering. Still, we don't have the best picture, so we then tried to use videos and interactivity to make this easier to understand. And this is one of the first videos that we have done, where we can see how does the flow of passengers changes in the city according to the time of day, and how many people is leaving a given place here in downtown city, how many people is arriving, and we can see the major flows in the city. Still, there's a lot of clutter here, so we want to do better, and we tried, and we start looking at edge bundling techniques. These are techniques for large, very, very big graphs, for visualizing big graphs, and here we are showing at blue the origins, at red the destinations. These paths, they are not connected to streets, they are showing you the major flows. Like here, there is a major flow from east to west, which is bigger from the flow from west to east. So this kind of techniques that we created in this project, or we extended, they can give you a very nice picture of what's happening in the city in terms of passenger mobility. We went further, and in collaboration with the London Underground and with the Transport for London, we have analyzed, using these same techniques, what happens in the London Tube, in the London Underground. And here we explore interactivity, where you can select the station, and you can see where does the traffic goes, where do people go from that station to others. We can see wider circles where stations get more people. And this is actually very useful for them, and they were very happy with this kind of interaction. They usually look at very large tables that are very difficult to make some sense, and here they can interactively explore where do people go, where do people come from. They can go from station to station very easily. They can select sets of stations and having a very clear idea of the flow. But when we did this and we showed this to them, they wanted more. They wanted, okay, but now we have surveys. We are asking to London people if they go from A to B, when they go to work, for instance, which train do they take, which line, in which station do they change trains? So we joined this survey data, and we created graph visualizations that are true to the network of the tube and allows to evaluate where is the stress in the network at different periods of day. And we see it red, the regions where there is more stress. We can see in these pie charts the amount of people coming, people going, and this takes into account the interchanges that people do when they want to go from one station to another using several different lines. And for dealing with case of missing data, we also develop graph algorithms that try to find the most probable route from A to B, taking into account the time of travel and the number of train exchanges. So, what can we do more with this vehicular network? And this has been extensively talked today by Susanna and by Tanya, which is using vehicles for carrying data from sensors that we can have in the city. And this is just one more application. We can use the same graph visualization techniques to see which are the roadside units or the access points that are getting data from the different points. So we can see the paths, we can see at red, which are at strong red, which are the access points that have more data coming in, and which access points are more or less responsible for the data coming from different parts, which enables us to analyze the network and to plan how to extend it and where to install more access points. And we can measure how much time this data needs to travel from A to B in a delay tolerant fashion. So we have, and this picture is actually outdated. We are creating a new one. This was when the number of access points were pretty much lower than now, less than half, but still we have a lot of places where we can get data in less than 15 minutes here in downtown and here near the harbor, and even here in the northeast. And we can also measure how frequently can we get data from each point. So one thing is how much time do we need to take data from A to the cloud, and another thing is how much data can we get per day. We analyzed how many garbage containers would we be able to get data from if they had sensors, and by using the vehicular network alone, we estimated that around 2/3 of the containers of the city council are in reach of the network, and more than half of the water meters can also be reached without additional technology. And finally, these sensors that Tanya has talked about can also be reached using this technology. So we have the freedom to put them in places that have no connectivity, where 3G or cellular is not good. So a lot of advantages, as my colleagues talked to you about. And finally, we can get all this data and put it in a dashboard where you can see what's the temperature in Porto and how does it changes from place to place. What about humidity? What about the wind? And we can connect to APIs from third parties, and here we are seeing the average velocity of the vehicles of the municipality, which has a different technology. And here we can see the average velocity of the buses. We can see how it varies. We can have an idea if there is traffic or if it isn't, how much Wi-Fi sessions we have, how much people we have in the streets. So basically, creating a place where we can gather all information from all these sensors and networks. So this is all that I want to show to you. I just left a couple of videos so you can see different patterns. In the top left, you can see Porto and how Porto traffic changes along the day in a more artistic way, and the same thing for London. Very different patterns, just to let you with some flavor, and then you can see more videos in the screen that we have in the exhibition. So thank you very much. Hope you enjoyed it.